the last 10 years, night vision has become increasingly popular in the firearms industry. It's now not just a device reserved for the military or even for people who are very serious about hog hunting. And the education has also improved. A lot of people understand much better how to utilize night vision, how to train with night vision, but there's still a piece that is missing that a lot of people don't know a whole lot about, and that is how the devices themselves are manufactured, or in this case, how they're assembled. In 2023, T.REX ARMS began working with Scott from Nocturnality to provide us with high quality controlled night vision units of various models. And that has been very popular, and we've outfitted hundreds of people with night vision devices. But what I'd like to do is actually travel out to his facility and see firsthand how these devices are assembled, quality controlled, and created. So let's go find out how that's done. All right, guys, so we are here in Kentucky now at Nocturnality. Scott is going to be walking me through, because I'm personally very interested in this process because I've never seen it. I've used night vision quite a lot, but I've never seen how it all comes together, exactly how many parts it is. So Scott is going to be showing me how night vision works and showing you guys what he does with the business and what kind of services he can provide you guys. So, Scott.
Yeah, welcome everybody. We're here at Nocturnality HQ. Nocturnality is our night vision business. We've been in operation since 2019, so we're in year 5, 6 range right now. That whole time, things have changed a little bit, but not, we've kind of always had sort of one mission and one kind of business model, which is a lot of very, custom build night vision type of stuff. Picking your image intensifiers, your housings, and doing some assembly work for people, as well as service of existing night vision units. And then in 2023, we got together with Lucas and the guys in T.REX and to supply them with a specific kind of product lineup that we've talked about in other videos. And so I guess today, we're going to go through that assembly process a little bit in some detail, but we're also going to talk about some of the other stuff that we have here, some of the equipment, some of the quality assurance procedures, talk about some of the misconceptions, I guess, that I think people have about what it is that this type of business does, what our role is in creating a quality product and adding value to the industry. So we'll get into all of that. And before we do that, let's talk about some components, and let's talk about some equipment. We'll walk around the shop a little bit and see what we have here and what we use it for. Cool? Cool. So we were starting here at sort of like our prep, stage, I guess you could say. We had a goggle laid out there. It's kind of like how we normally would before a build, but there's some stuff that would have had to have taken place before that, which we'll get to when we actually go to kind of start the assembly process. But over here, this would be kind of like our primary assembly area with some equipment here I'll talk about. Air guns are super important for night vision assembly. This is something where one of the main things that we have to combat, and when we assemble a night vision device, obviously, is making sure that when you're looking through a night vision device, you're only seeing the best quality image that you can, and part of that is making sure that debris, any other foreign material, is obviously not interfering with that, right? So air guns and other tools as well are involved in that process of we're just constantly applying air to all the component surfaces, all the optical surfaces, making sure debris is not in that in the cavities and not obscuring the image in any way. So we have air guns at different stations here. This type of electrical equipment, the soldering station, testing, and all that stuff up here in front of me, that's more of specialized for, a lot of it is service for night vision devices that come in that maybe need image intensifier modifications. And we'll talk about what an image intensifier is, like exactly at the component level, but just know that there are different formats of image intensifiers, and you have to obviously match those up with different housings, but sometimes in order to do that, you have to do some modifications to an image intensifier tube that might involve something like desoldering an electrical circuit, stuff like that. So that's what we would do here. This right here is an air hood, Sentry Air Systems air hood. Air hoods are, there's, as we talk about getting into some of the misconceptions, they're a nice tool to have and they can be useful. What this machine does is basically pull air from the ambient environment into a controlled environment, and during the process it's filtering that at a very high level. So if you did have a lot of particulate in the air that you wouldn't want to end up inside of a night vision system, you could have a truly clean kind of region to do some of the assembly and stuff like that. Getting right into one of the misconceptions is this, if your ambient air is relatively clean, a lot of the particulate matter that we battle and that we have to fight against for night vision assembly actually is created during the assembly process with like mating surfaces together,
Right.
threading things together. It creates shavings and different particulate matter that we wouldn't want in a goggle. So this actually doesn't deal with that because that happens with the components themselves. It doesn't
Right.
matter where you're assembling it, you're going to get that and you have to fight against it. This would be used more for if you have particulate in the air, which we also actually have an overhead filtration, a general area filtration system in here as well. So this doesn't get used a whole lot. This would be used for like if we needed to take apart an image intensifier module itself and really control the quality of the air in that. So it's another tool in the toolbox. And then I would say over here to my right further is more the interesting stuff. We have a series of, over here is night vision test equipment for doing like night vision specific quality assurance and testing different aspects of a completed night vision system, or at least a semi-completed night vision system. We have the classic, I think a lot of people are more familiar with, like nitrogen purging of night vision for longevity and basically checking the vacuum seal to make sure it's sealed from the elements and submersible to all the right degrees of water resistance and everything. This particular piece of equipment right here, this is the Hoffman 126A, probably I would say the industry standard as far as general quality assurance checks, different services that this machine can do to a night vision system, like checking the gain level. Mm-hmm. Image intensifiers, as they have a lifespan, right? So
Right.
as you use them, some things with them degrade in terms of performance, and one of the things is the gain level. So it's kind of like over time, the brightness of the tube essentially will decrease more and more and more, which makes it a less effective night vision device. This can measure your gain level of a tube, which essentially kind of gives you a report on like, how much life has it got left? Yeah, exactly. If you have a gain mismatch, you can test individual tubes and kind of figure that out. Also, this is very important for goggle collimation, which is an important process in the assembly, important quality assurance process mm-hmm. in the assembly of a goggle, where you want to make sure that if in a bino, right, both tubes are kind of aligned properly in the same direction, so that your brain is not having to do extra work to realign, out of aligned goggles or tubes. This machine is, I would say, primarily used for stuff like that, checking the infinity focus so that you can get a proper focus. And that's also what these machines are over here. These are infinity focus check machines. We'll go over all this in more detail as we get into the assembly process. And this is, a lot of the equipment that we actually use here at Nocturnality to create a quality product and supply all your night vision.
Yeah, awesome.
All right, so we're over here. We're gonna walk through the assembly process, right? We talked about that over the prep station. The first part of that assembly process is you got to have some tubes, to put in a goggle. When you're doing a goggle, which is actually two tubes, right? There's a certain selection process that we would typically do to make sure that as a complete system with both tubes and two eyes working at the same time, you're getting the best experience, right? So there's like a criteria that we would go through. Now, image tubes, we've talked about in other videos, right? Most of the, if it's a current production tube, most of the time, and in all T.REX case, they're going to come with this tube data sheet that has a record of various performance tests, and that's kind of what this process is we're selecting tubes that are going to make sense to put together and be used in tandem, right? So there are some misconceptions, I think, as well, and during this process. I think a lot of the industry is kind of selling a message of how important this exactly is, mm-hmm. and there is a reason why we do it, but as far as how closely do two tubes have to be matched on certain metrics, I think there's some misconceptions there. So a lot of times when we're selecting tubes for a binocular system, what we're looking for is stuff like the signal to noise ratio being like probably the single most important metric of an image intensifier. We want to try, here, this is our standard, is we want to try to keep the two signal to noise ratios within 10% of one another. Any more than that, you might end up with an image tube or a night vision device where one side of the image is a little bit noisier than the other, and when our brains combine images, you'll tend to see that you'll kind of like fall to that lowest kind of common denominator. So we want to try to keep a 10% gap, for example, in the signal to noise ratio. Other things that you would match on is something like center resolution values. Again, we don't believe in a goggle that's super important, but also like if we have the ability to keep center resolution values either the same or within one maybe step change, 64 versus 72, we would want to try to match up tubes based on that as well. And then the other important metrics, the actual luminance gain of the image tube itself, that would kind of equate to the brightness level that you'd see. That's a pre-controlled and a preset level when image tubes are manufactured. So they're always going to be close enough probably to match without any actual issue. But again, this is where we can take things a little bit further and make sure, okay, like tube gain you want within, probably 3 to 5% of both tubes, so you don't have a kind of a weird brightness mismatch going on. That's the type of stuff when we select image tubes. The other thing that's important when you select image tubes in a goggle specifically is you have your spot chart. You're familiar with that?
Right, yep.
That's where when they, L3 Harris, for example, when they manufacture an image tube, there's some inherent kind of imperfections in the image in the form of either dark spots or light spots or whatever. Above a certain size, they record those on these spot charts, and when you're matching tubes up, a lot of times, this is one of the more critical things, maybe more so even than like the actual specifications, is you don't want to have two, tubes where the spots are super concentrated, maybe say, for example, in the center zones, or if you have one tube that's super clean, and you have the option of choosing other tubes that are also either very clean or very spotty, you kind of want to take all these things into consideration if you're doing, like, for example, a build for T.REX. We would use that as one of the primary criteria for matching tubes, is just how those cosmetic defects are going to come together in a complete device. Are they going to make it marketable and something that somebody would be happy with, or we're taking that type of stuff into account. So
now I'm assuming when you're doing that, if you have like a little one down here in the bottom left and then this one has one in the top right, you would prefer to do that so when they're merged you're not noticing both together, versus you wouldn't want two that are both bottom left because it'll be more concentrated.
We try to take all of that into account. So when your brain combines images, a lot of times if you're running a bino the correct way with kind of like one sort of merged circle, right? You'll basically pick up the blems in either, if you have blems spots in both tubes, like they'll kind of just come together. So we take that into consideration if it makes more sense to swap a tube left-right, because the orientation of the defect would be different from the left pod or the right pod, maybe be more preferable one or the other, we would do that. So we're kind of using that also as a criteria where we're picking some of these things and putting them together in systems.
Nice. So we have 3 different packaging styles, it looks like. So Photonis sells their image intensifiers in this nice little, it's a nice little canister. And then this is Elbit.
These are Elbit systems, Gen 3,
Just comes in this thing. And then L3.
This is what you would see with an L3 image tube right here.
How would you tell, I don't know if it's sheets or not, if something is white phos or a green phos?
You would typically tell that by the product, one of the product codes, and it's independent of the manufacturer. So an Elbit tube would have a different certain product codes for green and white, versus L3.
Okay, but the biggest question that I have, and the real reason why I'm down here, is I need you to tell me about red phosphor tubes used for hunting demons.
Yes.
I need to know.
Yes.
Is it real?
I don't personally know. However, we have heard the rumors, and we do not sell red phosphor tubes on purpose.
But they do exist?
They do exist, and they have existed for a long time. They almost have mythical properties, I'm told. But
have you ever seen one?
I have seen one in real life. I've seen one. I've not seen anything crazy through it, but I also haven't been in the right environment, I think.
You've been in Vietnam?
Yeah, I haven't been
during a war?
Right,
okay,
exactly,
all right.
yes. Now we're back over here at assembly. We're going to talk about some of the components, the key components of a night vision device. Before we're going to build this up, and actually this is going to be one of your all's units. So we're going to build one of your T.REX RNVG-A units with L3 intensifiers right here. But before we do that, let's talk about all of the things that go into a night vision system. We kind of have them laid out here in sort of like a front to back, fashion, starting with your eyepiece lenses, which are these guys right here. That's obviously the end that you look through. The quality of lenses obviously is a very important aspect of a quality night vision system. There's been some debate over, which lenses are best, how important is that actually in the image that you see. It definitely is a factor for sure in terms of the quality of the image that you see. And if you really kind of step back from everything and you think about like what is the point of wearing night vision, or what is a night vision device supposed to do, really conceptually we say that it's supposed to just recreate what we're naturally able to see as best as possible, right? Because if we just had natural superpower night vision and could run around without goggles on and see in the dark, that'd be awesome. This is the next best thing. So we're trying to recreate that. So a quality lens, this is a US made salvo lens. Quality lenses like this, Fujinon, all those are all, we've kind of tested them all, and they're all, we have a list of approved suppliers of which ones are good enough. There's not too many that aren't, what I would say are good enough, but there definitely are more kind of like AliExpress, type of lenses
stuff.
for, Temu stuff for home builders and things like that. Sure, great. There's kind of a cutoff there where, there's a certain level that you want, and then maybe below that there's a few things that you don't run into too much outside of that. So your eyepiece lenses are here. You always have some in any type of housing, whether it's a bino, whatever, you have some accessory parts here. These are like a tube retaining ring, basically to keep some of the components in place, as you jostle it around and drop it and bang it up. This is something called a light pipe right here, which is kind of an important piece for any onboard indicator lights. Basically the role of this is to kind of like, pipe light from an internal indicator into the viewing area so you can see it. If the goggle's trying to tell you something like, hey, your IR beacon's on and you're giving us, our position away, you get a visual indicator, right? And that's made possible by the light pipe. I'll skip the image tube. I'll say that for last because that's the most important part, but the image tubes are here in the middle. This is actually, a housing, right? So this is kind of like, some people call this like a shell or something like that. This is basically what the important components go into, and it also has some important electronics integrated into it. This is an RNVG-A housing. We call this the articulating style, which we talk about in other videos, but the housing is a very important piece of the complete system. Obviously, you have some, these are like an infinity focus stop ring. This is a dual purpose with a D-collar to also hold your front lenses in the system, so you can't just turn them all the way out of the system and they fall on the ground. These are actually more important than you would think. This is an aluminum ring, very simple. It's not anything fancy, but these are more important than you think because these actually control the travel distance of your objective lens, which is also very important. And basically what you don't want to happen is your objective lens being able to turn and travel inside the housing and contact the image tube inside the housing, right? That would not be good. You don't want anything really touching the image tube inside the goggle. And obviously this piece plays a really important role in your water resistance and as well in shaping the quality of the image that you see, because this is doing the light bending and light gathering of the system. And then so finally we're back to, this is actually what makes the magic happen. This is the image intensifier tube. You mentioned you've never seen one of these in in real life. Probably a lot of people really haven't. Even if you do have a night vision device, you wouldn't necessarily like see this individual component. This is actually completely vacuum sealed, and it kind of inert in its own right. So you can actually dunk these in water, submerge them. Like this is a self-contained system for the most part. It's actually very robust. Like obviously these are expensive. These are the thing that makes all the magic happen. You kind of want to baby them, and naturally that's kind of the the intent, or I'm sorry, the reaction of people. But really these are actually pretty robust and kind of self-contained. So light enters on one side of these and is amplified within kind of this self-contained unit, and then this screen on the back is actually literally what you're looking at through a night vision device. This screen lights up and kind of recreates that image that is also then kind of shaped and made usable by the lens.
Is this also where the LED indicator is?
So no, the LEDs actually are inside the housing on these electronics inside. You can see like there's an electronic circuit board in each pod, so that's where your indicator lights are. These guys really don't have a whole lot of anything special in terms of extra features or parts. In this L3 image intensifier and in any image intensifier tube, there's different, we call them formats. They all basically look like this. Is a standard 18mm tube. The different formats of tubes are usually for, whether it's intended for a PVS-14 or a monocular device that has onboard manual gain control, or if it's for like an Anvis style, which is the old aviator goggles, which you're a fan of, which doesn't have anything. You can see there's nothing kind of protruding from this this shell, like an electrical connector. So tubes either basically have the electrical connector, we call that the EGAC. They either have that or they don't. And in some cases, we might have to modify an image tube to make it compatible with a specific housing. In this case, the L3 image tubes are easily modifiable. You just connect, disconnect. Other ones like L-bit intensifiers, you have to solder, desolder. But that's really all that's going on with an image tube. They're both complex and simple at the same time. And that brings me to one of the kind of the themes of this video as well that we want to touch on is misconceptions about night vision manufacturing and night vision assembly. A lot of people, I think, the perception is like lab coats and clean rooms and lots of like really high, Breaking Bad stuff, right? Yeah. Exactly. That is very much associated with the manufacture of this subcomponent, the image intensifier. Those types of controls and quality assurance, it's a very detailed and technically complex process. Not a lot is known, about it. It's kind of like trade secret type stuff, ITAR controlled. That level of intensity in terms of like the processes and the controls and everything is I think people associate that with night vision devices, but really it's very much controlled to the image tube itself. You can see we're not in lab coats. We are not necessarily, and we have filtration, we have different quality controls, but this looks a lot different than I think that a lot of people kind of imagine when they think about assembling night vision. And this is industry standard as well. Like some of the biggest night vision manufacturers in the world work in facilities that look and feel just like this. We've been to them, we've toured them and we've seen them. And there's that kind of misconception of, it's super secretive and it's super controlled and all this stuff. And what the role of Nocturnality and any of our competitors and other companies is as far as taking components and assembling them in a complete device is, again, in my opinion, making sure that the device, such that it can, is able to recreate your natural vision as best as possible. So we don't want any, unnecessary debris in the device that might cause like image blems or dark spots that shouldn't be there. We want all the quality of the lenses and the subcomponents. We want it to do as best as it can do, right? So that's our role as a custom night vision manufacturer. We also want to do things like selecting properly matched image tubes and all these things that go into it that we'll talk about when we build this thing. All right, so after selecting image intensifier tubes, which we just talked about, now we're kind of like in our I would call this the prep stage. This is where our first step of cleaning various surfaces, cleaning, especially the optical surfaces of the lenses as well as the image tubes, and then also just kind of like a, quick air gunning of all the housing, the internal cavities, everything like that. This is sort of the first stage of that kind of like general QC process. What we would do typically in this stage as well also is lubricate your various seals, which are on the two lens assemblies for each one. You want to lubricate those with, this is the preferred, the mil-spec lubricant, Krytox. I think this is AC240, 240 AC, yep. That's kind of like the preferred. You can also use stuff like dielectric grease. Honestly, works pretty good. This is obviously the approved, so that's what we would want to use on builds like that. But a lot of times, the important point is you want to lubricate seals so that it retains its vacuum seal, right? So that's an important part of the aspect of the assembly process. Keeping the vacuum seal, keeping all moisture and everything out of the system itself. That's one of the most important things, one of the most important roles of the whole process. So at this stage, we're going to use something like an air gun. Your home builders are using like canned air and stuff like that. Also effective. You can get all the way up to like, pressurized compressed air systems and stuff like that. These air guns we'll use we want to hit like I said, all your optical surfaces, image tubes and lenses. So you also have optical surfaces as well on the image tubes. These are probably, like sometimes these come to us fairly dirty. for whatever reason, you know, we're receiving these and they definitely need some love. You always want to hit these with air probably first, in case, like in this case, you can actually see, if you step in here, like in catching the light, you can see various particulate on here. This is not uncommon for when image tubes get to us. A lot of times they have, you know, particulate on them. You want to hit them with air first. Sometimes you need some physical help to do that. So at this stage, we'll start with some air. And then it helps to have, you know, the lighting in here helps. So you can see some of that remains. What's interesting is that as the more and more of this you do, obviously we've built probably about 1,200-ish systems at this point.
Right.
You know, you start seeing some patterns and some common things. You can start to do things like catch inside of this. Obviously you can see through the glass inside the image tube itself. Some of what you're seeing in there is actually inherent into the tube, and that would result in
and not on the surface.
Right, exactly. So some of that are the spots that you can see on the data sheet. Sometimes you see stuff in the image tube that for whatever reason is not visible in the image. It's just part of the image tube manufacturing process. The more of this you do, the more you can kind of just like take a quick look and be like, that's, you know, we need to address this, or that's inherent to the image tube. So if you have anything like that, a lot of times a good, really high quality microfiber, you know, you don't obviously want certain types of materials contacting important optical surfaces. So we use something like this really super high content microfiber. It's not going to leave any additional fibers on the screen that would defeat the purpose. And you just want to use a soft touch here to kind of, you know, if any of these to defeat those little particles, you know, just kind of loosen them a little bit, and then they'll probably come all the way off at the end with the air again. You always want to do air first, and then, you know, to get anything, you're not dragging anything across the screen, right? And then we'll hit it with air one more time. There we go. You would do the same on this image tube, and then probably the last for prep before you do any lubricant is it's always good to take a look inside the housings. These are obviously all aluminum, right? So these have been machined, these have been cut. When you cut any metal or anything, you know, any material, generally speaking, shavings, especially threading. Threading is like the main thing when components are threaded together and they're obviously creating friction. That's where you get, you know, you might not think about tons of particulate material, but like on a night vision level and this type of level, like the littlest, tiniest little particles, you know, ideally not want to get in there. So the air gun again would be a first step in just doing the cavities in here, hitting the electronics, everything like that. And then at this stage, the last, you know, one of the final things that we do, I already mentioned lubrication of the seals. We've already built this unit out and disassembled it, so these are actually already lubricated. That's where the use of the gloves comes in. This is not necessarily for ESD purposes, the gloves. It's more just because, you know, if you read the label on this, you don't want to necessarily have this on your skin a whole lot. So you want to get some lubricant. The seals are really the important part. That way they don't degrade as fast over time. You can keep that vacuum seal on the goggle, which, again, to reiterate, is probably like one of the most important things that you want to check for at the end of the process, which we'll do. You want to make sure this is a vacuum sealed system, and the seals are the critical part of that. So that's pretty much it for the, you know, kind of the overview of the prep process. Next, we would go to like more of the actual assembly, which is where you're putting these things together, actually assembling it in a complete device. And so we'll get into that next.
Cool.
Got a little dye on there. All right, and then because we had metal on metal contact inside the goggle with those screwing in, I'm gonna hit it with air again. A little hack at this stage to see if you have any tiny little particles sitting on that back lens surface, as if when there's no tubes in it, if you turn it around like this, anything inside now looks super big. If it's close on the back screen, you can kind of look and see if you see anything. Any black spots or anything, looks good. Tubes are going to go in this. This surface goes in first, so we always check this, clean this one first. Got to hit it with a little air. Cloth, gently. Check it in the light. Internal only. Get one more look on the back side lens there, looks pretty good. So now we're going to insert this tube right here, line it up, and then to get it in the notch, use just some kind of tool here to gently get it perfectly into place there. Light pipe, you got to get in the right orientation so that it actually does its job. Make sure there's nothing on the piece itself that could then be sandwiched in there. There we go, make sure not to touch the tube screen. Tube retaining ring goes on top of that. This is where you're going to have a lot of that metal on metal threading action, creating shavings and stuff in there. Okay, we'll clean both of them at the same time after they're both in there. So now I'm going to do the right pod. That actually looks good. See something down in there, I'm going to hit with this. There we go. Light pipe. Retaining ring. Now we got to check the back, the output surface of the tubes. That's where you'll see some stuff. Get this one wipe here. And making sure every little piece of thread, I just pulled a little piece of threading off from where it had been threaded in there, and that would have been eventually worked itself loose and landed on the tube screen. And then somebody would have been like, there's a hair in my goggle. It's not hair. It's the threads of either this surface or this surface. They get, when you turn that on there and they just get pulled off, they'll look like hair, but they're not. It's little tiny, tiny, thin pieces of plastic. If you feel too much resistance, you know that you're just going to be generating all that stuff. So you want to make sure it feels smooth. And you would never know what to feel for, you know, until you've done it a whole lot. Okay, so the first time you do it, obviously, we've already built this, so this isn't as necessary, but we would unthread once we build, or once we thread that on the first time, and we would look, and you can see a little bit of stuff on there, nothing too egregious because we've already done this process like 4 times at this point. But when you have the metal threads into the plastic threads, especially, plastic on plastic does it too, but especially the metal, it's kind of sharp, and you can probably cut your finger if you just run across like that. That will generate that material. So it'll stop doing that with enough cleaning, enough repetitions, right? And then you're going to check. Okay, we're good to do it like here. And then the final check to know, like, is it passing or not? Is it good? Is it truly clean or is it not? Is when you power them up, you look through it, you'll know whether or not there's, you know, debris in there. Undo it, check. The next step involves turning the lights off so I can power the goggle up and look through the screen and see if there's any debris that's obvious that needs to then come back out. And you don't have to turn the lights off for that, but I find that it's better if you do, because you'll get like glare and, you know, weird stuff as you're looking through this in super bright lights that might obscure or make things look a little different. I think you always want to look through it from the user's perspective, right, to make sure that everything looks like it should at this step. There's a lot more QC that happens after this, but this is kind of like the first, you know, it's assembled, it's not complete, nothing's locked down, it's not collimated, it's not purged or anything. But at this point, you would want to power it up, look through the tubes, and you're just looking for debris in there, basically. All right, semi-completed goggle right here. Everything's been put together. We've checked to make sure as far as debris and everything, you know, the image is as clean as it's going to get. That's kind of like the important part of the previous steps. Now we're on to what is, you know, kind of the meat and potatoes of quality assurance and making sure this is set up the best that it can be to provide the best possible image. One of those main steps that we'll probably start with is on this Hoffman 126A set. And this is kind of where, like, you know, professional tools for professional, you know, quality products comes into play. This is one of the main, you know, kind of like industry standard professional tools that we use for the collimation. But it's interesting because we can also use a setup with some just sort of off the shelf optics aligned like this to kind of demonstrate the concept of collimation, which is what we're going to start doing. Collimation is when you have a binocular system, 2 tubes, meant to be viewed obviously by a human with 2 eyes. It's kind of like, essentially you can think of it as sort of like making sure that the 2 are in best alignment as they can, a passing alignment, so that you don't have, when you're looking through it, you don't experience any like weird, you know, kind of like disorienting sort of effects or excessive eye fatigue and eye strain that can maybe over a long period of time introduce some issues. I kind of think that, you know, there's a little bit of this vendor community sort of like overemphasizing certain elements of this, like collimation can be, you know, perfect or not quite as good or whatever. If you use the tools, you know, the way they're intended to, it's kind of like a pass-fail. You know, there's so many individual factors that could go on as far as like experiencing headaches, right? You've heard people like experiencing headaches or eye strain or whatever. There's so many factors that could cause that using night vision. It may not necessarily be due to the collimation process. So we look at collimation as sort of like a pass-fail. If you look in the, you know, use the tool as it's intended, that is kind of like the purpose of it. It's a pass-fail. It's not necessarily a, you know, perfect, not as perfect, whatever. So that's what we're going to do here. What we do to start this process actually is what's called zeroing the diopters. You know, obviously you've been using PVS 31s and stuff forever. They don't have the diopters, the adjustable ones anyways. On a more standard kind of like PVS 14 style system like this, you have these adjustable diopters, something we didn't show before on camera because we had actually already built the system up before and deconstructed it. was making sure that your diopters are set, mechanically, so that the stopping point is at the +2 on the indicator, and then all the way through to -6. Because sometimes when you get these lenses, they won't be like that. The stopping point will be sort of arbitrarily like in the middle of the range, which is what you don't want. So we've already set these up to be good to go that way. But there's another process as far as zeroing the diopter that you use this machine for. We're on our infinity focus test, but we'll set it to the eyepiece diopter test here, just on the reticle control. So you set your diopters to the 0 points on the dials there, and then you're going to use something. This tool right here is it's basically a 10x scope kind of that you can kind of put on here, and we've already got this set up to operate on this, and you set this on here. You're going to power up your goggle, and what I'm looking at right now is like a test screen. I'm going to put it back on this reticle here.
You want it in focus, I'm assuming.
Right, you want it in focus. So we're going to make sure that we're seeing what we want to see here, adjusting so that everything's as good as it can possibly look to start with, so that you have the proper reference points. So what we're doing now is we're basically going to be, it's called, the process again I mentioned is called zeroing the diopter, but basically what you're doing is you're setting this up so that the end user is going to have,
starts on the defaults.
Yeah, they're going to have the very full adjustment range in case they need it, and not some sort of more limited range because it wasn't set, kind of at this true neutral point from the beginning.
Makes sense.
Yeah, and what's interesting too is if you look through there right now, can you tell, you can see like the most finite elements of the tube screen down to like these tiny, tiny little defects that your eye would never be able to see.
Oh yeah, because we're magnified.
Yeah, we're magnified at 10x, right? So that just that's a good tool to demonstrate, like,
oh yeah,
all tubes basically at some point have some things going on with them, some imperfections. And when you look at it with the diopter scope at 10x, I mean, you can see like the little hexagon pattern of the screen and everything. So that's just a interesting kind of takeaway from this process too. And then now we're doing the other side here. Okay. All right. That's what we want to see. Okay. I'm going to cut power there. Now we're going to start the actual collimation process. You have to truly do this, you have to have this thing called a collimation bridge, which you affix onto the machine like so. And what this does is it allows you to only basically use one eye at a time.
Right.
Because if you're using both eyes to look through this, our brains are naturally good at like combining things the way that we know we kind of need them to look or whatever. But what you don't want to happen is your brain doing work to make that combination, or more work than it needs to. So you use this bridge to use one eye at a time, so that you're not getting that latent sort of like, brain processing effect. You're setting this up, you're setting the channels up independent of one another in alignment, and then when you look at them together, they're just naturally in alignment, and your brain's not having to do any work to like kind of put them together. That's sort of like the whole point of the collimation process. So I'll turn the goggle on there. All right. So if you want to look through there, you can kind of see, you see the reticle, the black box, that most central little dotted box. That's like the best zone that you can possibly be in. And so as you rotate those eyepieces, you would see the crosshairs kind of aligning over that and changing, right? So you can see it's in the most acceptable or the most perfect box that you can get. That's one of the great qualities of the RNVG-A and the AB series goggles. They collimate really well. And so that's kind of like the final check to see, okay, it's collimated.
Yeah.
Yep. And then you would just lock your eyepiece rings in with the spanner wrench so that these now can't turn and it can't mess the collimation up. This is the nitrogen purging. On the RNVG-A, you have purgeable pods. So there's two, and you actually have a extra one on the bridge if you need it. But you're plugging.
Oh, it's a screw that comes out.
Yeah. You undo your
access to it.
Yep. So there's an O-ring on this screw, and then obviously on your purge adapter there's an O-ring as well. So you just connect right in there. So the nitrogen purging process is kind of a final, there's really two elements to it. One is, I would say the most important part is that we're going to actually put this under vacuum and make sure that it holds a vacuum, because that's going to tell you it's as weather resistant as element, resistant as it possibly can be. So that's the important part. And from a maintenance perspective, you talk about like, do I need to get my devices re-purged or whatever? I would argue maybe it's not as important to put more nitrogen in the system if, in case it leaked out, but it is maybe important over time to periodically check to make sure that it can still hold a vacuum seal, because that basically means you're making sure that it's still waterproof, it's still...
stuff's not getting in there.
Yeah, exactly. Yeah. So that's kind of part of this process. Plug it up, we're gonna pump into vacuum here, and you can see as long as that needle's not moving or going back towards zero too quickly, it should stay basically in one spot there. So that tells you that it's holding. The kind of minimal accepted standard is negative 20 inches of mercury is considered passing for vacuum seal for night vision. And then we've got it hooked up to our nitrogen tank down here. And then all you do is just you're pumping some nitrogen into the system there. And then typically you would repeat this process probably like 2 to 3 times just to make sure that you've pulled all, potentially moist or not perfect air out of the system, and you've replaced it with nitrogen. That's going to give you the best, kind of like, I guess, device longevity. The main thing is just in case there was any moisture in the system already during assembly, which there wouldn't be in here, but you never know, and things can happen. You're pulling all of that out, and then you're replacing it with perfectly dry controlled nitrogen in, and then you're sealing it back up, and it's good to go.
What happens if you do too much?
If you do too much nitrogen?
Sure. Or is that not an option?
That's not really an issue. The air we breathe, 78% nitrogen or whatever that comes out to, so that's not bad. Dry nitrogen is the main thing, is like it's coming from a dry source, so it's really just a moisture control thing. So
cool.
Yep, you would just undo your adapter here.
And then put the screw back in like as soon as possible.
Yeah, plug it. You can plug it with your thumb. Make sure that actually can hold vacuum, and then you just go right in there like that. And perfectly sealed. There we go. So the last step, actually, I might have said this was the last step. The last step actually is setting the infinity focus of the device with the infinity focus rings here, and we'll do that back on the Hoffman test equipment. This is kind of cool too, and it's actually really important. So let's do that next. Cool. This is usually the last step of the process. You can do this on this other Hoffman machine, the ANV 2020, but the 126 also does it in kind of a neat way as well. This is what we're going to do, is set the infinity focus point of the device, or set the infinity stops, I guess is more technically correct. Obviously, night vision can focus. You set the focal distance of where things look clear versus where they're going to be out of focus. What you want in any night vision device is a stop that will, when you're going out towards infinity focus, which is where you probably want the device most of the time, is you want it to stop, not too far, stop the travel of the lens, not too far past infinity, or sometimes ideally like right at infinity. And the reason why you want to do that is because you can kind of like chase your focus around. If the device can focus further than infinity, then basically nothing's in focus, and then it's not very useful. And so you can kind of get into like sort of chasing a zero with a rifle. You can get into kind of like chasing your focal point in the device. So you make a physical stop with these rings somewhere right at or just past the point of infinity. It would be ideal to set it just past the point of infinity, because if you set it too close to perfectly infinity, the dimensions of the stop ring sometimes can change in cold and warm, and if they swell or change and basically get to the point where the lens can't rotate enough to get to infinity because you set it super close, now suddenly your device is like kind of useless, because if you can't focus at infinity, then you don't want that, right? So what you do in this is, it's very simple. You have a resolution pattern in here, or an infinity focus pattern. You're going to set this to where it gets basically perfect, and then you're going to go just a little past that, and then you pretty much just set your ring kind of to where now if I were to try to focus anymore, it would hit the physical stop. You got to do that on both sides. All right. So I've done that, and then these are held in place by some little grub screws that you just tighten down here, so you know that they're not going to turn anymore, and change your setting.
Now, as far as maintenance goes, there's lots of little screws and like hex keys and things.
Sure.
I've never had anything back out, at least I don't think, on my devices. Is that ever something that customers need to worry about if they are on vehicles a lot, and so there's vibration, or shooting a lot, and
yeah.
it's getting rattled?
These, specifically what we just did actually, these are the tiniest little grub screws that you can get.
Right.
Sometimes the process of turning and applying pressure to these rings like this, I mean, it's possible. I mean, it's extremely rare, but it is possible.
It's possible, yeah. You're not adding thread locker or Loctite.
You don't want to lock these down necessarily, just because, just in case you, like, for example, in this process right here, we set it to where we think it needs to be. What we would do is then go check to make sure, confirm that it is where we want it to be. So you can't really then go and redo that again just to apply thread locker. It's kind of it would be a never-ending process. So yeah, as far as stuff, maintenance and backing out, like,
check it maybe if you're concerned. But
and really the only one that you really want to do is maybe possibly just make sure, give this ring a quick twist.
Because they get the most attention from turning it.
Right, they would get the most tension. And then obviously on articulating goggles, like, nothing's going to back out, but your pod tension, specifically in the RNVG-A, can maybe loosen up a little bit, and that's actually adjustable right there. So those aren't going to go anywhere, but you can mess with those if you want to. So now we have pretty much a completed RNVG-A. When we actually build these, like, for real, we would go and hit the lenses with air one more time, make sure any little dusties are just blown off of there, just so it looks nice and pretty. We'd give it another check or two in one of the test patterns just to make sure, we get the best picture we can. The cool thing about the 2020 here is that it actually converts a pattern into a Snellen chart for your visual acuity, like 20/20 vision. That's where the name comes from. If you can see the 20, if you can make out the differences in the line pairs on what you would see in there, if you looked in there like the 20 number, that means you're able to achieve 20/20 vision while looking through your night vision device. That's a cool test.
Right.
Most devices these days, tubes are good enough, lenses and everything are good enough. You can get 20/20 vision through your night vision device, which is the best that this machine can even test for. So that's kind of a cool difference between these two. This one, it actually translates to, like, real world, like, look in there, can I get 20/20 vision? Great. If you can, that's the best it can get.
Cool. That's awesome.
There we go. All right, so we showed you a little bit of behind the scenes process of how night vision is assembled. There's a big difference between how some of the components are actually made, right? That's one of the things that we're talking about at the beginning. Image tube manufacturing often gets conflated with night vision device production, complete device versus individual components. The quality and the professional tools definitely play a big role in the overall end user experience. It's not necessarily the same home building night vision or whatever versus a professionally built device, but there's different ways to do it, and we've developed a process here over, I think we've built about 1,200 night vision devices now. I use night vision roughly speaking, about 500 hours a year. That's kind of conservative. We probably look through and evaluate and see roughly 1,000 tubes in a year now at this point. So we kind of know what to look for. We've learned definitely what's important, in terms of how it relates to the end user, because we're also out there using the night vision that we build all the time. And we can take those insights back to the process here, refine anything, if we need to. And a lot of the stuff that we showed as far as equipment and processes and stuff, important, we highlight the ones that are really important for the actual end user, and also, for production as we scale up and we need to do more and more, some things change and equipment comes in, and a lot of times it's purely related to that and not necessarily related to, a one-off build, how it turns out and the quality and everything like that. So was this what you expected, or anything surprise you?
Obviously seeing how the night vision is assembled, I've known a little bit about how the night vision market, works, but seeing the equipment up close and seeing, the rigorous activity that goes into quality control checks, that's always something that I'm looking at as I'm touring factories. The way I see night vision, particularly, what we saw today, is it's very similar to the AR market. There's a lot of people out there, a lot of the rifle companies out there are not actually producing the parts that they're making rifles with. They are simply assembling. They're collecting parts, bolts, barrels, rails, whatever it happens to be, and then they're using their own quality control checks, their own experience in manufacturing a rifle or assembling a rifle to then create a final product. And that's essentially what is happening here. Scott is going out and researching, and he's constantly texting me all the time as well, like, hey, there's this thing that's coming out, this thing's happening, you come out and visit us often and tell us what's up. And so constantly updating and improving the product and the different parts that are available, and then taking the appropriate stuff, assembling it with quality control checks, using all the different equipment to create a high-end product. So it's very similar to a company. I believe this is a LaRue rifle. They make many of the parts themselves, but they're assembling to a high standard. And that's what I saw here. And what gives me confidence in our company working with Scott is that he's an end user. There are many night vision companies out there that are producing similar units. You can go buy similar product from probably half a dozen other companies. And this is a high dollar spend item. You probably want to, do a bunch of research, and you've probably seen a lot of videos from Scott and his company. But what gives me confidence in working with Nocturnality is he's an end user. He's going out into the range. He's running classes. He's staying up to date on what products, what's going on in the market. And I haven't always seen that with some of the other night vision companies out there, and that's something that's very important to us here at T.REX ARMS. So I appreciate you showing us the process of taking the guts from the different companies, which you could. I don't know if a night vision tube is either the bolt or the barrel, but it's
it might be both.
Analogy-wise, it's probably both actually. And then you have the housing, the rail, and all the other bits that go on. So I appreciate you showing us that. It's been super informative, and I hope you guys learned something from this video and can have more confidence in purchasing night vision devices, whether it's from T.REX ARMS, whether it's from Scott at Nocturnality, or whether it's from another company who's engaging in the same kind of activity. Thanks for watching, and we'll see you guys next time.